So welcome back to the class. So in this class we will see introduction to asymptotic notations. So asymptotic notations are very important in computer science and engineering in algorithms. So so why these asymptotic notations are very important in algorithms we will discuss. So this will play a important role in algorithms. So suppose coming to computer science and engineering, these asymptotic notations are very important because in computer science and engineering we have to solve a large number of complex problems. So in order to solve any complex problems, we should we should do we should able to give some certain algorithms in order to solve in a less amount of time. So coming to computer science fields will be having some problems. So we have to solve those problems. So if we want to solve those problems, we need to write a program for the given problem. So in whatever the language that we write, whether in C language or whether in Python or irrespective of the programming language, we have to write a program for the given problem. So uh, for writing the program, we need some algorithm. So if we want to write any program for the given problem, for that purpose, we need some algorithm. So by using this algorithm, we can able to write a program for the given problem, so that we can able to solve such a problem. Suppose there is a problem. So for that problem, we are having different types of algorithms like A1, A2, A3, A4, and so on. So these are the algorithms that are available in order to solve the problem. So in which algorithm I should use for the given problem? Which algorithm should I prefer for the given problem? So it means how can we decide which algorithm is best for the given problem and which algorithm is suitable for the given problem like that. So this design and analysis of algorithm will decide which will give um, it will give clarity how to which algorithm we should use and which algorithm we should prefer for the given problem. So in order to in order to select those algorithms for the given problem, basically it is depending on the two factors. First one is time complexity, it means time, and next one is memory. So why we are taking these two factors, time and memory, is so suppose there are various algorithms for the given problem. So whichever the algorithm is taking less time in order to finish that, in order to solve that problem, we have to select that algorithm because we want that only. So which algorithm will take less time to complete that problem, we have to prefer that. So next one is memory. Memory means the amount of space that we use for the problem. So while solving problem, not only we have to consider that time complexity, but also we have to consider memory. So whatever the algorithm that is taking less memory for the given problem, we have to consider that. So by considering this less time and less memory, well, based on the time and memory, we have to choose the algorithm for the given problem. So whatever the algorithm that is giving that is taking less time and less memory, that is the best option which is suitable for the solving the problem. So that is what we are seeing. So whenever you are given a problem, and there are some various algorithms in order to solve a problem. So at that point of time, we have to conserve only time and memory for the solving the problem. So whatever the algorithm that is taking less time and less memory, that is the best option that we that we choose in order to solve any problem. So based on these two factors, we have to choose the best algorithm for solving the problem. So now we will see asymptotic notations. So there are three asymptotic notations that are big bow, big omega, and big theta. Now we will see what is meant by big bow. So big bow means big bow can be represented like a big circle. Here see we are drawing, we are taking a graph. It means we are taking x-axis and y-axis. In x-axis, I am considering in n. It means n defines the input size, and y-axis I have taken t. T defines the time complexity. It means the amount of time that it is taking. So from this axis, I am taking one curved line from this. So this line is gradually increasing from year to year. It means this is the f of n. So what is this f of n represent means rate of growth of time. It means time is varying from time to time and also it is increasing linearly. So this is f of n. So this f of n will represent the rate of growth of time. Next one, this line will represent the C into G of n. So what is this G of n means input size. So this so this C into G of n is always greater than the f of n. It means f of n is less than or equal to C into J of n. So in coming to big O notation, so always the inputs always the rate of growth of time is less than the input size. It means input size is very high. So whenever the input size is greater than the rate of growth of time, we can say that it is big O notation. So here see the condition f of n is less than or equal to c into g of n. So this is the condition for the big O notation where n is greater than or equal to n naught. And also what do this c and n will represent means they are real numbers where where c is greater than 0 and also n naught is greater than or equal to 1. Why? Because it is greater than or equal to 1 means minimum the output minimum the output should be 1. It means we have to get minimum 1 output. So that's why it is greater than or equal to 1. So finally f of n is equal to big O of g of n. So what is this big O represents means f of n is less than or equal to c into g of n. It means g of n is bigger than the f of n. That is what it is indicating. So this is the big O notation. So now let us take one example. So here see f of n is equal to 3n plus 2 and g of n equal to n. So now I am checking the condition f of I am writing like this. So f of n is equal to big O of g of n. So when we can say this f of n equal to big O of g of n means where f of n is less than or equal to c into g of n and also c is greater than 0 because 0 into something is not valid. That's why c should be greater than 0 and also n naught should be greater than or equal to 1. So here see f of n is less than or equal to c into g of n. What is the f of n? 3n plus 2. 3n plus 2 is less than or equal to c into n. Now, what is the condition which this condition will satisfy? It means where f of n is less than or equal to c of n. This condition should be satisfied. In where c equal to 4, in this case, our condition will satisfy and it will become f of n equal to big O of g of n. So we have to take c equal to 4. So whenever you take the c equal to 4, 3n plus 2 is less than or equal to 4 into n. So now take the value of n and check the condition. So always, and also it should be greater than or equal to 2. So n value should be greater than or equal to 2. At that case only, this f of n will f of n is less than or equal to c of n into g of n. This condition will be satisfied. So uh, you can take the values from 2 to infinity and check the condition. Always it will satisfy this condition and also by satisfying this condition f of n is less than or equal to c into g of n, we can able to say that f of n equal to order of g of n. So here see f of n equal to 3n plus 2 and g of n equal to n. Now I can able to say this f of n equal to order of big O of g of n. It means g of n is greater than f of n where so this here, in this case, 3n plus 2, and if we compare this, in this case, we can able to say g of, in this case, we can able to say this 3n plus 2 is less than or equal to n. It means n is greater than 3n plus 2. In the same way, n square, n cube, and so on, n power n and 2 power n. These are also satisfies this condition. So by taking those conditions, always it will satisfy for the given condition. So this is what the big O notation. Next one, big omega. So if you take the graph and x-axis and y-axis, yes, see, this line will indicate this line is gradually increasing. This is f of n, and this line indicates the c into g of n. So in this case, what we have to consider is this f of n is greater than c into g of n. So this is the big omega. It means whatever the input size is there, that is less than the rate of growth of time. So f of n is greater than or equal to c into g of n, and also where n is greater than or equal to n naught, and also c should be greater than 0, and n naught should be greater than or equal to 1. So this is what the big omega. So in big omega case, always the f of n is greater than or equal to c into g of n. So this is the big omega. And also we will consider one example. See f of n equal to 3n plus 2 and g of n equal to n. Now now I am saying f of n equal to big O of g of n. It means f of n is greater than g of n. So c into g of n. It means I can able what is the value of f of n means 3n plus 2. So 3n plus 2 is greater than or equal to c of t into n. So here I can take the c value as 1. So whenever I will take the value c value as 1, it will become 3n plus 2 is greater than or equal to n. So so if you take the values right from the 1, always it is this condition satisfies. See, if you put the value of n 1 in place of n, 3 plus 2 5, 5 is greater than or equal to 1, yes, it is true. So right from the value of 1, it satisfies the condition. So this n this n naught should be greater than or equal to 1. So you take the values from 1 to n and substitute the values. So always this condition will satisfy. So the, from that we can able to say f of n equal to big omega of g of n. So big omega of g of n will represent f of n is greater than g of n. Big O represents f of n is less than g of n. So see here f of n equal to 3n plus 2 and g of n equal to n square. Suppose I have taken this example. Now 3n plus 2 is 3n plus 2 is big O of n square. It means 3n plus 2 is big O of c into n square. So based on the condition, and we have to take, it means if we take c equal to 1, and also there we have to put some conditions. So based on the conditions only, it should satisfy the given condition. So whenever this condition satisfies, it is big O of, sorry, big omega of g of n. Otherwise it will become big omega of g of n. And also we have take so that when it is when the condition satisfies, it will become f of n equal to big omega of n of n, big omega of n. So and also we have to take tightest upper form. So in place of n, if I take log n and log of n, so this f of n equal to big O of f. This f of n is greater than or equal to c into g of n. So by taking these values, the condition will satisfy, and this f of n, is always becomes greater than the 2 omega of n. So we have to take the tightest upper one. So from big omega, we have to consider only tightest upper bound. So that is what it is saying. Next one, big theta. So what is this big theta means? Suppose we are taking f of n. This first line represents c1 into g of n. So upper line will represent c2 into g of n. So from this, what we have to consider means, so how we will represent big theta means f of n equal to theta of big theta of g of n. So this is the representation of the big theta. So we are having c1 into g of n and c2 into g of n. So in middle we are having f of n. So this f of n should lie in between the c1 into g of n and c2 into g of n. It means this f of n should be greater than or equal to c1 into g of n, and also it should be lesser than the c2 into g of n, because c2 into g of n is greater. above the f of n and c1 into g of n is below the f of n. That's why it should be. Um, that's why it should be present in between those. And also where C1 and C2 are also greater than 0. And also n is always greater than or equal to n naught. So n naught also greater than or equal to 1. Why n naught is greater than or equal to 1 means at least it should be able to produce one output. That's why, and also we should have only at least one output. That's why it is greater than or equal to 1. So here take see the example f of in the previous example, if we consider this f of n equal to 3n plus 2 and g of n equal to n, now consider f of n is less than or equal to c into g of n. Now I am taking a value of c as 4. Now see 3n plus 2 is less than or equal to 4n. So where n naught is greater than or equal to 1. See, if we substitute the value, it will satisfy the condition. And also f of n is greater than or equal to c into g of n. It means 3n plus 2 is greater than or equal to n, where n is greater than or equal to 1. So if we take the value of, if we take n value from 1 to n, always these conditions will be satisfied. So this is what it is saying. So yes, here what we discussed, we have discussed big omega, big theta, and big O notations. So these are the three asymptotic notations which are present in the algorithms. So now we will see what will indicate. So we are having big theta, big omega, big O. So each one represents the each time complexity. So big O represents worst case complexity. It means upper bound. Always we have to present it upper bound. So we are also having this big omega. So what do this big omega represent? This it represents best case. It means we cannot go beyond this limit. If we go beyond this limit, it will become the worst case. So up to this limit only, it will become the best case. Next one, this so big theta. So what do this big theta will represent? Means it will represent the average case. So these are the time complexities. So these are the asymptotic notations which represents the time complexities of the algorithm. So the big theta will big omega always represents the worst case time complexity. Big big omega always represents the best case time complexity, and also big theta always represents the average case time complexity. So that is what it is saying. Suppose if I am taking one example, so suppose I am taking one array 5, 7, 1, 2, 4, 10, 12, 11. This is one of the example. So consider consider it as a linear set. So in this linear set, I will explain each and every case, and that is worst case, average case, and best case. So so if I want to search something in this array, so if I want to search the element 5, so the element 5 is found at the first position. So this is what best case. Best case means finding the element at short amount of time. It means we are finding that element in the beginning only. So that's why it is the best case. So why it is called best case means in the order of one complexity only we can able to find this element. It means only from the single element, only from the single search we are finding the target element. That's why it is called best case time complexity. Always the best case time complexity should be the best choice. It means what do this best case time complexity will represent means the element will be found always in the first position. It means whenever you are searching the element from in the array, it will be found at the beginning of the array. So this is the best case. It means um, from the constant amount of time only we are able to find the element. It means in constant time we are finding the target elements. That's why it is called best case time complexity. So in the order of one, we can able to find the target element. Suppose if I want to search the element level, it means we have to search all the elements and we have to compare all the elements till the end. It means We are going from the right from the start to the end. So in the linear fashion, we are searching the target element till the end. It means we are going until the end. So we are searching each and every element. So it will take the order of n complexity. This is the worst case. So what do this worst case means? We have to search all the elements and we have to compare all the elements and we have to go till the end. So this is the linear time complexity in which it will take the order of n time. So this is the worst case. Worst case means we are searching till the end or the element is not found even we have searched all the elements. That is the worst case time complexity. And now we will see average case. So what do this average case means? Order of n by 2. So order of n by 2 means um, it will become order of n only. So by using this average case also it will take the order of n complexity. So by using this linear sets, the best case time complexity is order of n because we are finding the given element, we are finding the target element at the first position. That's why it is called the best case time complexity, and also we are finding at the first position. And also we are finding the we are finding the target element at the last, or we are not able to find the element until even we have set all the elements. So this is called the worst case time complexity. So order of one is the worst case time complexity for the linear search. And also for the average case also, average time complexity also it will take the order of n. So this is the example for the time complexity in which it will define the worst case, best case, and average case. So worst case defines the big O, best case is represented in the big omega, and average case is represented in the big theta. So this is what we have discussed. So this is the asymptotic notation concept. So hope everyone understood. And so if you are having any doubts, please comment in the comment section so that I will reply to your comment and also I will solve your doubt. So these are the very, very important topic in the algorithms. Why? Because these are defining the time complexities for the given problem. So if you want to define the time complexities for any problem, we have to know this best case, worst case, and average case. So by using these cases, we can able to define the time complexities for the given problem. So hope everyone understood. And also, if you want more examples, I will I will take few more examples in order to understand those concepts. So we will see in the next video. Until then, bye.